data reduction, I have collected some slides to give you some hints why are we doing this why were we doing all that flagging? Okay, this data set that we are working on is quite well behaved. And in principle, the pipeline should be already flagging most of the byte data. But as you could see, sometimes these random points are not properly flagged by the pipeline, and they are left there. So the pipeline, after all, has been trained to have a criterion on when to discard, to flag antennas or flag byte data, but it's not perfect. So you may end up left with some random points. How important is to flag those points? Perhaps you say, 3 points here are not going to make any mess in my image, right? I have 10,000 points. Well, it depends on what are these points. You may have like 3 or 4 points that have like super big amplitudes, and that's going to cause you a mess in the image if you don't flag them. So these slides are just, I collected them from a talk at the NRAO school. But yeah, just to visualize what happens. Remember that the Fourier transform spaces. So narrow features in the UV plane are white in the image plane and the other way around. Okay, so when we are looking into the UV plane and we have like some narrow features there, when we image that, it will be translated in a white thing in our image. If we don't want that, we will have to get rid of those nasty points. Okay? And there is it's related to the Fourier transform spaces. If you have amplitude errors, when you make an image, you will get symmetric patterns in your image. If you have errors in the faces, when you make your image, you will have asymmetric patterns. I will show you some examples. Okay, so this is similar to what we were doing yesterday. Okay, we had some random amplitude points. Depending on how you display your data set, you will immediately see who is responsible of that bad data. In our case, we had scan 163, okay, and a couple of baselines. If you plot amplitude versus scan, you clearly see you have something there annoying. If you make the plot of amplitude versus UV distance, perhaps you don't see that scan, but then you will see the baselines that are wrong. Remember, UV distance is the measure of the baseline distance. So if we have plots, if you have like bad baselines, they will all have a peak at a certain UV distance. So then you can identify and flag them there. At the end, you want something that is kind of smooth. Sounds stupid, but you are like just deleting data that are not following the main behavior. This is an example. So this is what you expect for Jupiter. Remember that it's a sharp disk, so you expect something like that. But here you have like all these noisy points here, and these are clearly a very bad response. They are very low. So you want to flag all of these, because when you make the image of Jupiter, you will have a lot of ripples. And in our case, because our galaxy is not very bright, we can just like try to get rid of several small points that are noisy. It's much more clear when you have a bright source, because then all the amplitudes are much higher, and the noise with respect to the flags, it's much less. Anyway, so I show you here something, I hope it's more visual for you. So that would be an image with the VLA of a point source, that it's okay, it's perfect. But let's say we have 10% error in the amplitudes in all the antennas for a short time. So if I image that, I get something like that. So this is a result of having in the UV plane high amplitude points just for a short time. So clearly, that would be the result if we hadn't flagged our scan 163. We will have like nasty interference in our image. If you have, instead of amplitude errors, you have phase errors, you would expect, okay, this is, oh yeah, a phase error. This would be phase error, and this is amplitude error. So in the case of phase error, the ripples are antisymmetric. So in one side are positives, and in the other side are negatives, whereas in the amplitude, you have symmetric waves. This is just a way to see when you image, if you have like this kind of ripples, you may go back to your UV plane and flag some extra noisy points. And that was only for a short snapshot. But if you observe for a long time, then you are rotating your array. This is what you get at the end. So you don't want to image eyes when you want a point source. So, okay, this is just to, yeah. And the thing that we have been talking about, yes, tell me. This is not the difference?
I think it's the same.
Perhaps. Yeah. It looks like the same, you're right. It should be one positive and the other negative, right? But it looks to me the same. Should be to one side. Yeah, I grabbed them from there, from them. But yeah, they look the same. Okay, I'll look into that. Strange. In the previous one, you could see. Okay, and this is to explain you the problem of the missing short spacings. When you have like a very extended source, remember that the extended source goes to short distance in the UV plane. If you are missing that information, when you are imaging, you are trying to fit that. And if it's really super extended, you will not be able to image this part properly. So it's better if you just make a cut and discard the short baselines and try to use a single dish or something else in order to try to recover this information. Okay? And this is also a reminder, because you were all playing with the apps in SIM, selecting different cleaning boxes, the sizes. The better you determine the cleaning box, the better the image will be. Okay? So this is just an example to show you what is the final image if you make a very small box where the real signal is coming from. You have something like that. If you make a bigger box, you are starting to consider secondary peaks as real signal, and then you end up having much noisier result. And finally, if you make like a big box, you are cleaning. I mean, you are cleaning as well, but not so deep. The idea is that you want to recover as much flux as possible from your target. So you want to make a good box. Okay, and then how deep do you clean? Okay, if you don't clean much, if you are like, do not many iterations, then you may end up still with some holes near your bright sources. If you clean too much, then your sources will be like a lot of many point sources, which is not like continuous. The perfect case is this, but it's very difficult sometimes to achieve. Okay, and if you are really willing to play on what are the effects of amplitude and phase errors in your calibration, in your antennas, you can use apps in SIM. And it's explained in the exercise 2.8. You can go to the, to open AppSynSim and use some bars that are there to add errors in your antennas, and then you can see what happens in the image. This is a much faster way to see it than deducing ALMA data, but okay. So that's it for today. The slides for today were those, and the idea is that we keep working with the target that we were working on yesterday. We were here at the end of the page. There are some general recommendations that Anita wrote for doing images of data cubes. I guess we were all stuck. We didn't even manage to start the task clean. We were all stuck there. So you can open Casa, and instead of using the full 100 channel data set, we can use the one that you have just copied. We don't need to flag. Everything has been, it has been flagged already. It was just when yesterday we finished in the continuum subtraction and it crashed. So I had done that previously in my computer, so I just copied that data set in your computers. And what I did was to run the task split to take only a small amount of channels. So you could do that, which is, I think it's a good exercise as well if you want for getting used to Casa. Because now you have 8 channels, but let's say that perhaps you don't want to image all of them. You perhaps want to average them in a single one, and you only image that one. That is also okay. We are having 20 kilometer per second channels. You can average all of them and have just one image. That's also it's useful to do that for doing a first image and see where are the cleaning boxes that I want to do. And then after that, I image the whole data set, which is very big. So you could go to the terminal and, for instance, do input split. This is going to call the task split, and it's going to tell you all the parameters that you can choose. Okay? So they could be the input file, the output file. Then there are many, many options. You can make an average in time. You can make a cut in UV range. Let's say all my long baselines are bad, or it's just too much resolution. I only want to concentrate in the shortest baselines, and then that makes my data set much smaller and more easy to work with. So I can choose an UV range of less than 75 kilolambdas or whatever I want. You can keep the flags, or you can choose to just delete the data that has been flagged and keep only the good data. And you can do what I have been doing. Perhaps it's kind of cut. it's just very handy to have them in a text file to copy paste, or so in a whatever .py file that you can call from Casa. But you can also run tasks like this interactively, filling in the inputs as you wish. So it's very handy to have them in a text file that you can run, but you can also fill in this way. For instance, if you have all your commands in a .py file with all the Python commands that you want to perform, this is what the PI would do if they want to run all together. You do exec file blah blah blah.py, and then it will perform all the Python commands that you have in that file together with the Casa commands. Okay? So if you put all those commands that you are working on in a .py file, and you want to execute all of it, you can do it this way. Okay? So I don't know if you have started, guys, the cleaning of.
Before starting, what folder should we do the?
So, wait a second. Is it on? Because. Okay.
What folder should we make the security copy?
For the flagging,
Yes.
you want to flag more?
No, but in case.
Okay. Yes, yes. So then you go to Open Casa. That's a good question. And now the same command that we used flag data in the website. You can say get or get flag data. Yeah, flag manager. Yeah, this one. But instead of with that file, you want to change to the other one. Yeah, instead of consub. Yeah, you just need to add. Yeah. Yeah. I don't know. It doesn't allow you to go to the upper line. Okay. And if you here, okay. And then, it's not really, I think, sorry, okay. We can do, that was with this, if you paste with the percentage, I think it will respect, no, I'm wrong. Okay. Sorry. Too bad. And now we want
I think we could just copy the first line.
mode
then
save.
the
Yeah,
second
mode
line.
save, or we can just say, oh, sorry. Mode equals save, and then version name equals consub original, or something like that you want. That should work. Didn't because it's 2 lines. It's it's not really making, it's copying all of it. You could also do input flag, flag manager, and then you can do,
Like a script.
yeah, like this. Now we do this. This is the visibility file that we want to use, and then mode we want save. It's a different way of calling the same task. And then version, it doesn't name well. Okay, and then we check the inputs again. Okay,
Go.
and then go. You can do it. Are we in the right folder? No, we need to go to, yeah, to the folder. Yeah. Calibrated. No, it's okay. You do it. I think if you press tab, it should, yeah. And to the SDP, blah, blah, or,
I can just do this again. Right?
yeah, it will show you, and then you can do ls to make sure that you are in the, no, you still have to go one more.
Then I finish this. How do you get to this?
With a lot of Photoshop.
I saw this.
Yes.
I mean,
Okay, the ALMA data is that. Yes.
what are those colors telling us? Are those, is this image, I mean, we can do this image by the data we have?
Well, that was the data that we were looking at too, right? But this is this is a simulation on the. If you play it again, I think. This is to demonstrate that there is a satellite as well. Okay. So there is a very massive galaxy, and then it's distorting the image of your ring. This is what we are seeing in our data cube, right?
But what about the colors?
No, yeah. So this is not in our. This is an yeah. In our data set, we only have this red ring. Okay. This is the gas that we have been detecting, the CO gas that we have been detecting. But this is the central galaxy, and they have just put here only the optical image of a central galaxy to demonstrate how the light would be distorted.
So this is like an artist's impression?
Yes. But it's just to show what happens if you have like the original. The rings that we are seeing, it's just that the light is distorted. It comes from this is the gas from a galaxy that is behind that one. So they have made an artist's impression to show you what's happening. Why are we seeing a ring? But the final ring corresponds to the data that we are doing. Yeah, from our data we cannot, yeah. So for this, to this. From our data we cannot get the full movie. We are only getting the final ring shape.
Yes.
If you put it into a model, that's what they have done in order to make that video, is to use a model to end up with a similar ring as the one that we see. Okay?
And one final question.
Yeah.
Here they talk about angular resolution in mass. What is
Milliards seconds.
milliards? Oh, okay.
Yeah.
But-
One arc second divided in 1,000.
But wasn't this measured in radians?
You can measure as you wish. You can transform from radians to degrees, and then divide by 3,600 seconds, and then you get a second. And if you divide in 1,000, you have milliarc seconds. Yeah? Okay. Question?
Yeah, we have already done the cleaning,
Yes.
and we got this.
Uh-huh.
But we don't know how to do the mask.
Excellent. That's why I come in, right? So otherwise you can do it yourself. Only the people. No, for that you can check all the CASA documentation, but it's much faster if I do it.
Yeah.
Okay. If you select, let's say, I believe this signal is real, right? So
Okay.
I don't want to like clean that for the moment. So I'm going to take. You are choosing. Okay. These buttons are important. Okay. So depending on the button that you have selected, then your mouse will have a certain behavior.
Yeah.
We want to make a. I don't know. Okay. It's telling you that with my with my left, I'm a bit bipolar as well, but okay. With the right click of my mouse, I'm changing the brightness, and with the left, I should be changing the position. But so I want to make a region. So I select a region around this. Okay. And when I'm happy with it, I double click. Okay? That will be the cleaning box I'm going to use. You can choose, yeah, please come along. It will be, I'm sorry, it's secret. This will be the cleaning box that will go into the cleaning. Because I have several channels, I can choose to apply this cleaning box only to this channel or to all the channels. If this channel is, it's an example channel that more or less the rest look the same, I can use it as a cleaning box for all of them. Perhaps in the others you have like a spike or something and you want to clean it differently, okay? Let's say we can put it for all channels or for this channel, it's up to you. And you can also choose, because if you have different polarizations, you can choose to have different windows, cleaning boxes as well. And now, this window will be used for cleaning. But let's say I'm a bit picky and I don't want to clean the central part of the ring because I believe I don't think there is signal there, right? And we learned that the most perfect is the cleaning box, the better we'll be cleaning. So I can choose erase, and then the next box I'm going to select, it will not be taken into account for the cleaning. Okay? Let's say I make a box like this or something like that. I double click. And this kind of donut, this kind of region will be my cleaning box. Okay? Here I can choose my threshold, my iterations, my number of cycles. You can make this number low for the first iterations, and then you can check and modify if you want the cleaning boxes interactively. If you want to take a look to every step of the cleaning, you can click here. It will do the convolution for this major cycle, and then it will show you again the results so you can modify it at every step. If you say, no, I'm happy enough with this, I'm just going to wait until the end, you can press this. It will make all the cleaning process until you reach the threshold or whatever, and you have to do nothing. Or if you say, no, I'm tired of cleaning, I have enough, I can press stop. Okay, we can try to do like this, and then we'll start the cleaning, hopefully. Okay, starting cycle 1, so it's going to. So it's here you have all the input parameters that you have, and here it's telling you the size of the beam that it's restoring. So that would be your resolution. It's telling you the restoring beam with size, blah blah blah. This is going to be your PSF, your resolution. Yeah. So now it's a matter of yeah. And what you need to do is perhaps after your the iterations, you can check the residual image to see if you have patterns there that are telling you that you are not cleaning well enough. In this case, I mean, you don't have like super bright sources in your field that are really interesting to put a clean box on it. Otherwise, the cleaning goes too bad. I think if you just select like a big ring without even erasing the central part, you will get a good image out of it. If you leave this cleaning box for too much, or not too much, you may end up with negative holes in the center as well. So you have to take that into account when you are selecting cleaning boxes. I don't know how long will it take, because in the finalizing state it can stay a bit. So yeah, perhaps you guys can go and try to make your cleaning boxes as well. Can you check whether if it's working, like finalizing residual images? Okay, so he is writing something. Shouldn't take too much. So yeah, another thing you can, because yeah, you have copy-pasted all these cleaning options. There are many. So somebody took into having thinking, okay, it's good if I don't clean only point sources, but also different scales. You see that you have multi-scale option. So is cleaning different scales in your image already. You are not only cleaning point sources. You are, and then here you have the tapering as well that we have selected. So we are giving less weights to the longest baselines because they are much noisier. Yeah, you can choose the number of channels. If you don't want to image all of them, you can just image one, and then you have the feeling on what's going on because it takes a while. Yeah, and then we can perhaps talk later about the negative component. Or you can go to the help clean in the command line, and it will tell you all the inputs and an explanation. Or you can go to the website of Casa Clean, and there you have all the explanation of all the parameters that we are using. It takes a while to reach this level of specification, because usually you just start with choosing the image size, the cell size, the risk frequency, and go. And then you start choosing the rest. So you are lucky somebody else did it for you. Tell me.
I don't know why this isn't working. I try opening Casa.
Are you in the Casa folder? Oh yeah, okay. Casa release.
Flash Casa.
Yeah?
And
Now you go to the
calibrated data.
yes. Have you extracted that one?
Yes.
Okay.
I have bandwidth minus and minus.
Yeah, okay, so we want that one.